I'm Frank here. I'm the technical service advisor with WerkMaster, and I also do a lot of the training here. So we'll just get kind of started here. So thanks for your time. So we're going to talk about a lot of things today. You may not capture some of them. So I just want you to know that there are resources available. One of the main resources that I really draw on and I really focus customers look at is, and they come laminated on your machine there. It's a machine-specific tooling guides. Even for like a salesperson that's a little bit new to the bidding process, we really try and lay this out in a visual way. So I'll just give you a really quick example here, and you can just look at your guide. But for our surface preparation, we always illustrate a picture of the surface type, and these are all based on your machine. So if you've got glue on the floor, you would kind of go like, here's your surface. It would ask you, is this coating thicker than 1/8 of an inch? So for a salesperson bidding the job, he could, probably make that determination on the job site. And then if it is, you go with this tool. And if it isn't, you kind of go down this way, and it kind of gives you a choice based on your tooling type. That covers off the surface preparation aspect. And we've had some really good feedback from this page, and it just kind of, it demystifies everything. It'll send you in the right direction. The following page is system breakdown. So for instance, on the first page, it's how to polish concrete. And it gives you a few tips, but it tells you your process. So, again, if a sales guy is bidding on it, the customer wants a high grit polish, the sales guy can kind of look at it and say, well, hey, there's, 7 to 9 steps there. And, it helps to educate your customer. I even show the customer this sometimes, and they can kind of, like, why is this costing what it does? Well, it's this process. So we've always found the more you educate your customer, you become a consultant, and you're not really selling to them. You're telling them what they need. You're giving them a solution to their problem or what they're looking at. So that comes with every machine. And then all the machines also ship with a manual for its operation. So I'm going to cover off the main parts of the manual, but if you forget something, always refer back. So what we're going to talk about next, on the very bottom here, you've got a tooling choice based on a certain condition. And that condition is the surface hardness of a floor. This little tester here lets you test the condition of the concrete. Concrete is basically made from, you got your cement, you've got your aggregate, and you've got water. Those three are the main building blocks of concrete. But depending where you are and how the finisher has finished the concrete, that surface will always be a little bit different. So there is really no two slabs that are the same. So having a piece of test equipment lets the operator know what kind of condition he's kind of looking at. So we all know that concrete is hard. So it has a hard compressive strength. That really isn't a concern of ours. I mean, if that's a concern of ours, that's a really big problem. If you're falling through the slab, you've got bigger issues, and you're probably not too worried about polishing it. But what we're trying to do, we're not trying to find out the concrete's compressive strength. We're trying to find the concrete's abrasive strength. So the reason why we do that is, depending on the abrasive strength on the floor, that will determine what type of tool you use, what type of bond in the tool, not the grit, but the bond. WerkMaster uses 3 bonds. We've got a soft bond, a medium bond, and a hard bond. And depending on the test results of your scratch test, that points you in the direction of what bond you want to pick. Most machines that we sell ship with this white tool, and this is a medium bond, and medium should be like, that's your average. So your average concrete is medium. In a condition where, say, the concrete's been chemically treated, or it's been over power troweled. So if you've ever seen a slab that's really dark, that's done through the power troweling process, that condition may require a different tool. And that would be our gold bond, which use a soft matrix in the bond, and they use a geological grade diamond. We'll talk about that a little bit more. But so let's go back to, like, how do we figure out what bond we need? So what we do here, we use this scratch tester. And basically, there's a series of picks in the scratch tester. The 2-pick is actually made out of plastic, and the 9-tip which is this one here, is so hard it can actually scratch a diamond. If your floor doesn't scratch at a 9, that means your floor is as hard as a diamond. And that means that you're going to have some challenges cutting the floor. So if you're a sales guy and you go to a job and you're like, oh, I've got to cut this floor open, we're putting a polyaspartic down, and the floor is not scratching with a 9, you want to educate your customer and let them know, like, hey, this floor is pretty hard. In order to scratch it, it's going to take a little, in order to abrade it, it's going to take a little bit more time. And you want to make sure to relay that information to the installation team so they bring the right tool. So that would be the tool that you have for 9. Can you use this medium tool? You can, but it's going to take you considerably longer than this tool here with the geological grade diamond. What you do, I like to start with a 9 pick. I don't start with the softest pick and move my way up. I start with the hardest pick and move my way down. When the pick stops scratching, that means you've reached the hardness of the floor. That means the pick and the floor have equalized. They're at the same hardness. This isn't a complete science. There's a little bit of plus and minus, but just know that this tool is designed to give you a range. So the way you use this tool is that you just put it in your hand there. And I like to put my palm on the floor, and I let the pick do the work. So basically, I don't want to like put downward pressure and drag the tool. I want to basically just put my palm down and I let the pick make a scratch. And you can usually hear it and see it if it's scratching the floor. So we'll just go ahead and do this. So I usually scratch, 1 or 2 inches there. So I see that this 9 pick is scratching. So I thank my lucky stars and I'm like, phew, this floor is not as hard as a diamond. It shouldn't be that hard to cut. So I go and I just flip over to an 8 there. Well, I was actually scratching with an 8, sorry. So we'll just go down to our 7. And we just do, I just usually scratch next to it. Now this pick here, and it's probably a little hard to see, I can hear it scratching, but it's barely leaving a mark on the floor. So that means that this floor is actually pretty hard. It's actually, on the top range of this tool. So I would either, if I had this tool, if I only had this tool, I could definitely use this tool. But I think I would much prefer to use the geological grade diamond because the floor is it's probably over a 7, so it's probably a 7.5. So that's basically how you use this tool. This tool comes with a few little accessories here. It comes with a sharpening stone. So from time to time, the more you use this tool, the duller the tip will become. So what you want to do is just every once in a while, just give that a little bit of a sharpening there. You can use a bench grinder, but you got to be careful with the bench grinder is that you don't want to turn this tip red. If you turn the tip red, you're going to actually harden that tip and you will get some false readings. You might find that all your floors are a 9. I usually use a manual method. I usually just use this and maybe after I'm done testing, I'll just kind of sharpen them up a little bit. It also comes with a piece of glass and a little piece of copper there. And there's numbers on there. The copper has 5.5 and the little brass has 3.5. And this allows you to kind of calibrate your pressure, your hand pressure. So you can kind of find the 5 tip, and if you run it over the 3.5 and it's not scratching, well, you're not putting enough point pressure. So you can use these little tools to kind of calibrate your hand there. This is a tool that we've taken from the gemologist world. I'm sure they have a lot of other technical reasons why they have these things, but in our case, this is kind of how we work with this kit. And there's also, if you forget everything I've just said, there's also a little instructions manual there. So that kind of helps you determine that the hardness rating. Based on the results there, I've determined that I am going to use a gold bond tool there. On the spectrum, you've got your hard floor. For a really soft floor, so if your floor was, say, rained out or the surface was very, very soft, like you could scratch it with your fingernail, we use this hard bond tool. And the difference between the hard bond is that the metals in the alloys are harder. So they'll hold up to the soft environment. Soft concrete will create a lot of abrasive dust, and it can wear out your tools rather quickly. So that's why you would use this hard bond tool. You know, the more tools you show up to a job site with, the more options you have, obviously, right? But that's basically the difference between the alloy. The diamonds in these two are virtually the same. This hard bond will keep that alloy, the diamond in suspension, so it doesn't just evaporate on you. You'll see it. It happens to everybody at one point in their career. They'll do a job, and in 500 feet, they won't realize that they're on a really soft floor, and they will have eaten a set of tools. So hopefully this course will kind of help you not go down that rabbit hole, as it can be a little bit expensive. Tooling itself is called plug and go. So you don't need any tools to take the tools on and off this machine. Basically, I don't have the magnets in here. I've made it made it a little bit for demonstration purposes, but there's magnets in here, and they're very strong, and they hold those tools tight in place. But basically they just clip on and clip off. So you've got these two little shoes there, and they just kind of clip on in there, and that's as simple as that gets. Now we're going to talk about the bottom side of the machine here. So we've got our plug and go plate. And as you can see, we've got the gold tools set up on here. They're ready to cut. We're just going to cut the floor with a 70 grit today. If you turn this plate over, you have what's called a compression foam. And the machines ship with two compression foams. They ship with a soft foam, and then they ship with a hard foam. And you can see here that there's a size difference on this machine. For the tight machine, I believe they're almost the same size. They're just the different densities. So basically, a soft foam, when you put this on the machine, the soft foam allows for maximum contouring. So a lot of times when you're polishing a floor, you're trying to flatten the floor, but you don't need to get every single square inch. Contouring to the floor will save a little bit of time when you're doing a job. And you also get a more even finish. So when you flatten a floor and you have a high spot, when you flatten that high spot, you're going to see that you have aggregate under it. Some customers don't like that. Some customers do not want aggregate, no aggregate. They want more of an even finish. If that's the case, I would consider running your soft foams all the time there, and that will give you your max contour. The reverse is the case for the bigger foam. This foam here extends all the way to the edge there. And when you put your plate on, that thing is going to run pretty rigid. On certain surface prep jobs, or even sometimes in a garage setting where you don't want to have any bird baths. If you're doing a polyaspartic and your customer, you're all done, and he drives in the next day and it's raining, and he's complaining that he's getting bird baths, this might be a good way to eliminate that. This machine here becomes like a planer. That's why you would use that foam in that instance there. So just know that they both exist, and we give you options. And why do we give you options? Because we know that every slab is different. Where you are, you might have different aggregate. We use a lot of granite here. Some places use a lot of like limestone, like shale, like there's all sorts of different things. So we let you dial in the machine based on your condition. So if something's not going right, this is the first place that I start to kind of calibrate the machine. That's your plug and go plate. These are called shear pins. And basically what these do is that they allow this plate to connect into the machine and be driven and spun around. This plug and go plate, the shear pin, is actually engineered. This is a design break point. This will break before the belt in your machine breaks. It's really quick and easy to change this, not so much your belt there. So when does a belt break? Sometimes if you're doing a job and you say you haven't walked the floor, or there's so much glue on the floor and you can't see something underneath it, you might come and you might hit a bolt. That bolt, when you come in contact with that bolt, it will slow down one of these plates significantly versus the other plates, and that can stretch your belt and cause it to break. So what we've done is that we have the shear pin here, and all that shear pin is a screw and a pin there. We've got some videos on how to remove and install these shear pins. I don't have it right here with me, but when you're reassembling the shear pin, you want to put red Loctites on the threads and also inside the shaft here. If you don't do that, the vibration of the machine running on the floor will loosen this pin, and you'll find that, I get this as a tech call, the guys keep breaking the same shear pin over and over again, and it's usually 99.99% of the times, it's because someone did not put red Loctite. So, you know, when you're mobilizing on a job, you want to have a little toolkit. When the machines ship brand new, they actually come with a little bit of red Loctite, so we cover off your bases there, but probably not a bad idea to get a slightly bigger container of Loctite. This plate here, and different machines, this will look a little bit different. So if yours looks a little bit different, don't worry about it. This is called a grommet. So every machine has 2 grommets, and basically this, there's like a rubbery silicone material, and this kind of holds the shear pin, and it kind of gives it a little bit of flex as well. Sometimes when you break a shear pin, depending on how violent the hit was, how fast you had the machine going and stuff like that, you can, the shear pin will break, and it can actually damage your grommet. These cost about $1, and we sell them here, and we ship some extras with your machine, but you always want to have a little stockpile there. If this shear pin happens to damage this grommet, you want to change the grommet. You know, I inspect all these periodically, probably every, you know, once a quarter, or if I'm doing a really high-end polishing job, I want my machine to be really dialed in. I just make sure that these are in good shape. So I usually just put my finger inside, and as long as it's nice and smooth and not, you know, like scarred up in there where the shear pin's been bouncing around, then it's good to go. There's no set lifespan on these. It's when they become damaged, you just replace them. If you find that they start looking elongated, then, you know, just replace it. We really try and engineer, we try and make these things cheap so you can change them often, and it's not a, you know, a huge hassle time-wise and financial-wise. You know, a lot of machines, you have to like bring them into shop and overhaul them. These machines are designed to be serviced in the field relatively quickly so you can, you know, get back up and running. So I'm just putting my compression foam on there, and these just slide in like so. When the machine's brand new, sometimes they can be a little bit hard to slide in. So you can put a little bit of lubricant spray, that's orange Jigaloo. You can use a little bit of WD-40 and just kind of spray it on there, and that will allow these to slide in. But once you get a little bit of dust on this thing, you know, after your first time grinding, the dust in itself acts as a bit of a lubricant. So they're pretty easy to put in. Now what we want to do is adjust our dust skirt here. So again, everything on this machine does not need a tool to be serviced. Everything is just done with your hands. So the way you adjust the dust skirt is that you just pull the Velcro off, and you just basically align it just so you can, I usually just put it at where my tools, where they connect onto this little base plate here. So I usually just set my dust skirt about here, or a little bit below, just where the tool, where that white plate is. And I know that I've got compression foam, so when it drops on the floor, the dust skirt's gonna come a little bit closer. So anywhere between 1/8 and 1/4 inch, whatever that works out to be, you know, on your floor there. The lower, you want to leave a little bit of space in between the floor and your dust skirt. This dust skirt's made out of urethane, and if it starts to, if it comes in contact with the floor, it'll actually drag on the floor. It'll make your machine actually hard to push. So, you know, no one wants to do more work than they have to. So you want to avoid that. And the dust skirt will actually lift the machine a little bit while it's dragging, and you're not getting that downward pressure on your tool, and you could have diminished cutting there. So you just want to make sure you're in that sweet spot there. So there you know, I've got about 1/4 inch. By the time the machine hits the ground, it's probably going to be close to like 1/8 of an inch. So that's ideal. That's exactly what I'm looking for. Here you just tighten the side up here. It's all Velcro. And then you just put your little middle bit in there. A little bit of gap as well will also allow that air to kind of rush in. So as your vacuum's working, the vacuum port is sucking, but there's also a little bit of air coming in. So it's drawing in that air. If you had the skirt up too high, you've got too much a volume of air, and you could diminish your kind of CFM flow in there. So, you know, if you notice that something's not going right, that's usually the first thing I check. I've seen guys, they kind of put the skirt, and, you know, if you're not paying attention, they'll kind of have one side cocked. So one side of the machine's dragging, and then I get a call saying my machine is leaving a weird scratch pattern, like just on one corner. You know, what's wrong with your machine? And it's usually not a problem with the machine, as this is all like, you know, engineered on like heavy stock aluminum there. It's usually something hanging up. So if this is holding up, if this corner here is being suspended by the skirt, well, obviously now the machine is going to be rocked into the floor, and you're going to have a little funny angle there. Not a huge deal when you're prepping a floor for a polyaspartic, but if you're doing a polishing job and you got like, you know, 10,000 feet of that, you know, you've just created a lot of extra work for yourself. So, you know, these are the little tricks there, little tips that will eliminate that from happening. And, you know, you always want to be as productive as you can on a job site there. So, yeah, you just make sure it's all sealed up and you're good to go there. So all these machines ship out as a 3-phase machine. But we also send you out this little adapter here. And what that does is it converts your machine from 3-phase into a single-phase machine. So all you would do there is you put your plug in there, like so. And now you're at single phase, so you've got 120, 120 in ground. And now we're just going to plug that in. That conversion is made without any user adjustments. So the user doesn't have to do anything to make that happen. So that's we've got some intelligence built into this VFD to detect incoming current. And based on that, it will automatically adjust. So whether 3-phase or single phase 230, this machine will run no problem there. So this is pretty basic stuff here, but we'll just go through it. So this here is the display panel of the machine here. Let's start with this corner here. So that would be your top left corner. It says REM. That stands for remote. So when you see that, that is an indicator that this control panel, everything that's on here, all these little buttons, they do not work. We've moved all the controls up to the handle, and we'll go over the handle, but you know, that makes life easy for everybody. You don't have to push buttons here. You don't have to bend over. The machine's in remote, and that tells you that the controls are moved up in there. Carson, I have a little error there. See that says voltage range? I wonder if that's just a low volt once you start. Okay. Okay, so I see that there's a lot of intelligence coming off this panel. So I just saw a little error message there, and it says voltage range. That could be an indicator that I do not have enough voltage coming into my machine, but we'll go and we'll see if that's an issue. I might just have a bad plug or something. But that's the voltage range. Your manual has all the little codes out there as well. So if you have one of those codes, just refer back to the manual there. So the next thing we're going to talk about is this number here, 976 pad speed. The PAD pad speed there stands for, if I were to turn this machine on, this thing would go up to 976. So there's a little dial, and we'll show you that later here, a little dial on your handle, and that's how you control the pad speed. So I like to start the machine at its lowest setting there. If it wasn't in remote, you would control the pad speed with these buttons here. So that would be a bit of a pain in the butt. So that's why we've brought them up to the handle there. So that's your pad speed there. That 0% there, that means that there's no load on this motor right now. Say you're going through a really thick, heavy coating, and you're getting an error message saying like voltage range, and this thing here says like 99%. That means that you're putting the motor under 99% load, and you know, you might want to back off a little bit and you know, either adjust your tools, run different tools, or change your a certain operating condition, as you may just cut out the VFD. This VFD always protects the motor. It always protects the machine. It will shut itself down before any damage is incurred to the machine. And that's a good thing. That's what you want. You don't want the thing to run at 150% and you have to order one of these VFDs, or one of your cord ends starts to melt and catch fire on you. So there's a lot of safety features in there. So this in essence though is all that control panel is really telling you, whether or not you have an error or a whether or not it's in REM. If it does go out of REM, you can refer back to your manual, or you can call us and we'll tell you how to put it back into REM. It usually doesn't go out of REM, but I find that guys who don't know what they're doing with the machine at all, they start pushing these buttons like crazy, and it kind of does like a bit of a brute force attack, and it will throw the machine back into sort of like a maintenance mode or a stock mode. So, you know, that's the first question I ask guys, like, oh, it's out of REM. I go, well, were you pushing these buttons all over the place? And they're like, yeah, we were. Okay, well, that's fine. We'll show you how to get it back into REM and avoid, you know, making contact with these buttons for the reason that the controls are in the handle. There we go. This one here has a lever, which if you just hit on its own does nothing. It requires the operator to push a button and activate the lever in order for it to spin there. And that's just a safety feature there. So someone doesn't just grab the handle and, you know, walk away and the machine's spinning and it's, you know, all sorts of craziness. There's your potentiometer. So when we saw that number being turned up and turned down, the pad speed, that dial was doing that. That's doing that work there. On the Titan XT, that potentiometer is just on the side here. So all the machines have a potentiometer. Depending on the machine, it's in a slightly different location there. We're going to adjust our handle into a comfortable operating condition. And we're going to hook up a vacuum. If we tip back this machine real quick, and this is for the polishing guys there. Perfect, thanks. Thanks, Carson. You'll see that the way that these plates are configured here, right? If you run this machine in a straight line, and I'll show you here, we're going to get a really hard cut running it straight because we have all this tooling contact, which is a good thing. It makes the machine very aggressive. But if you're polishing a floor and you're running the machine totally straight, like a lawnmower back and forth, you're going to get like cornrows, or you're going to get some tracking in your floor, and that's not a desirable condition. I mean, that doesn't really look good. So what we do is that we have a technique, and as long as you do this technique with a machine, life is good and you have no issues there. So, but I want you to see that dynamic. Can everyone see that, you know, you're going to get a concentration of cut if you run it straight like that. So I'm adjusting the handle to a position that's comfortable for me. And then I'm just going to get my zap strap there. And this is not how your machines will ship. You'll have sort of a nice location or zap straps that are built in. So let's pretend that this here, that's our wall here. We don't want to start at the wall. We want to work in towards the wall. So I'm just going to show you here the technique. Starting at the lower speed, about 550. I'm going to put a little bit of, do you want to just pan up just a little bit? I just put a little bit of downward force. It's a soft start. And what I do is that I run my machine straight. And then I come back and I S over it. And that's going to break up that pattern there. Like so. I'm going a little bit slower here just to show you the motion. And then what I do is that I come back and I just overlap by one plate. So about 6 inches in my case. All right. And I just started S-ing over it back. And you can see I'm getting a nice even cut on the floor. If I run the machine just straight and fast, and I don't S over it, I'm going to get that there, almost that cornrow effect there. So if you're running your machine like that, that's the result you're going to get. If you follow this technique here, you're going to get a way better cut, and that's called a refined floor there. You want to run your machine in both north-south and east-west positions on your metal cuts for sure, and I strongly recommend all your cuts like that. You just get a better looking floor. If you're doing surface prep, you can get away with a hybrid version of this, but I would go this way and then that way. North, south, and east, west, and that's going to get rid of some of your high spots by doing that. So I'm just going to clean this up now. And then I'm just going to run the edge. You want to get a little bit closer on the edge? Like to just bump off the wall there. So guys, I'm just going to go ahead and do that one more time, just so you can see it. So I'm going to go back to my start position. So my start position is that I run the machine straight. Just with a very, very slight wiggle there, just ever so slight, straight. I S over it back. And then I'm going to overlap by one plate there. And then I go straight again. S over it back. Overlap by one plate, straight. So, you know, the cutting's pretty straightforward. You know, I usually run in paths about 8 to 10 feet. I like doing this because you get a better concentrated cut, and it's also better management of your cords and your power cords. If you're running the machine back and forth, like I'll see guys doing warehouses like that, And, you know, at the end of the day, their legs all sore because they've been kicking this cord, you know, needlessly, right? So work to within your what your equipment can do. So depending on the vacuum you have, you've got a, you know, 25 to 33 foot cord. So, you know, like if you stay within that middle, about 10 feet there, that cord's not going to be in your way too much, right? And always, as you can see, I'm always working away from my cords. You don't want to work into your cords, so you're not having to, like, you know, constantly kick and all that kind of stuff. Okay, so I'm happy with the floor there. You can kind of see it's nice and even. What we're going to do now is we're going to vacuum the floor, and we're just going to inspect our 70 grit metal. Just want to make sure that we've evenly cut the floor and we're not getting any of these weird little, you know, like little circles there that we kind of saw, or any tracking like that. This wand has a little dial on it. I wasn't making a whole lot of pressure with it, so I'm just going to turn it so I get a little bit more pressure on my wand. Like sanding a piece of wood, basically we start with a coarse grit and then we move our way up. Once we get into the polishing stage, well, we're going to be at a very high grit. So the polishing process works like any other polishing process. The higher the grit, the shinier it's going to get. But we have to follow the steps to that. We can't go from a 70 grit to a 1500 grit. If we look at our tooling guide, we've got to go from 70 to 100, 200, 400, 800, 1500. So it's a process of steps. Before we can actually start polishing as well, we're going to harden the floor, and I'm going to show you that. This is about 70% of your job, is that metal cut. So now what we're going to do is we're going to move into the 100 grit, and the 100 grit is a different type of tool. It's a resin-based transition tool. We call ours like the achromic. It's kind of like a magic eraser. What we do is that we just take these off. And what we do is that we take the foams off, and the 100 grit tools, they're resin back. So they go on this this Velcro plate, and they just stick on. So it's like Velcro. It's like your running shoes when you're a kid. A little tip here with these ones, this is the configuration. It looks a lot like the metal plates. So we're kind of following suit there. Little tip to put these on. This here are the two shear pin holes. We call this this line here. If you connect these two bolts there, it makes a bit of a line. This is where on either side of this line is where the plate is going to be its most rigid. So what we like to do is put the tools on either side of that. You know, if you just do that, you're consistently putting the tools on the same way, and you're going to get a little bit of movement here. So these tools here allow, you know, if you have a little bit of a bowl there, you're going to get more the tools to kind of bowl in a little bit. So that with your soft compression foams there is going to make life a little bit easier for you. So you just put those on there. And if you refer back, as you start going through the process, if you go into your manual or into your tooling guide, sorry, you'll see that the speed, you start to increase your speed on the machine, and also increase your walking speed a little bit. And I'll show you that there. What we're going to do here is this tool is quite proud. These plates are a little bit thicker. So we're just going to adjust our skirt at this time. Adjust my skirt. So I've got about an 1/8 gap from the tool. Lift this side up. And you're good to go. You always want to run your vacuum for every stage as well. You're always going to get a little bit of dust. All right, just a little bit of pressure down on the machine just to get overcome that soft start. A lot of guys actually start their polishing at 100. If you've got a nice clean slab and there's no reason to expose any aggregate, you can start at this, and it's definitely a really quick way to polish the floor. You see I'm going a little bit quicker, but I'm still trying to maintain that technique there where I'm getting good coverage on the floor. And this is where the magic of our machine comes in. We can get so close to the wall. Normally you'd have to do this with a hand machine, a little hand edger. So this saves a tremendous amount of time and work. You know, just stay loose on the machine. You'll let the machine do all the work. You want to avoid stopping the machine. If you stop the machine while it's running, it's just going to core into the floor. So you've kind of seen that I've just always kept it fluid there. So say I get distracted or I have to pull away, I just kind of turn the machine off, or just kind of move it like that. Don't just let it spin in place. We've done the 100 grit, and if you look at our tooling guide, this is where the floor is actually very smooth. It's quite refined. So now we're ready to polish that floor. So remember what I said previously, like once you're out of the 100 grit stage, if your floor doesn't look good, if it's got like weird patches, if it has any metal tool scratches, you got to go back and you got to get them out. You know, sometimes you can try spray misting a little bit of water. We've got some videos on some scratch removal techniques, but you want your floor to look pretty darn good now. It's not going to look shiny, but you want your canvas, this kind of nice white floor, to look good. And you know, I like to look at the rocks, make sure that there's no scratches from the metals, like a 70 grit metal scratch in there. What can happen is that the scratches will kind of pop. The shinier the floor is. So if you imagine a black car with bad bodywork, you know, once you start putting that clear coat on a black car, you see the scratches, right? So that's kind of the mindset that I take when I'm doing this work. You know, I always relate it back to something else that I do in life or have done. So the densification process is pretty straightforward. And what do I mean by densifying? There is a lithium silicate part of this, our densifier, and that actually reacts with the surface of the floor, and it actually hardens the floor. I won't go into the science of it, but that's basically the premise of this product. This product can be used in two ways. It can be used as a regular lithium silicate densifier. You would put it down on your floor, you work it in, you wait for it to dry, and then you start polishing. But this product can, and we'll send you a video link. This product can also be put down on the floor, and then with a machine, with a 100 grit, actually you work in the product into the floor to make a slurry paste. And what that slurry paste will do is that if you have any small pinholes, it'll fill that up, and then you got to take that off again with the 100s. But that gives you your premium floors. You know, if you're doing like a $10, $12 a foot polish, money's no object. The customer wants perfection. They want to have all the little pinholes filled. Then this product used in that manner is the way to go. This process can, in the slurry method though, requires a drying time. So I like to put this down, make the slurry paste, and I like to get on it the next day. You can get on it to after a few hours, but I find that if you can let this dry overnight, you just get way better results. So if you're going to spend the time and effort to do it, might as well do it right. Do it the next day. So we use our applicator pad here, just on a Velcro applicator. And I've got this product in here already. Okay, we create some pressure here. Now you want this product to dwell on the floor. And what I mean by dwell is the floor needs to stay wet for at least 15 minutes in order for this silicate to react with the surface of the floor, and that's going to make the floor a lot harder. If this product dries too quickly, it's not reacting. So you might have to do a second coat, or what you can do is pre-soak the floor with some water and then put this on top. All right, so you put a good amount down. Put some on your applicator pad there. Like so. I'm going to put enough down so I can just drag it and do the entire floor with one go. This product you want to push in. So you're creating a chemical reaction. Do not let this product just sit on the surface. if you do, it'll just react with itself and you could get some weird things happening. You can get a little bit of film forming. So, you know, just know what you're doing. You're creating, you wanted to put this into the floor because you're trying to create a chemical process to react with the surface. You don't want to let this pool. So, you know, like with everything, just, you know, take your time, do it properly. You don't have to worry about a wet edge or leaving a wet edge, but you do, see I'm pushing it there, pushing it in. But I get a lot of guys that will let the densifier dry overnight, but it's not necessary. Just so when it's dry, you can just hit it. So it's usually about half an hour, 45 minutes, an hour. One of the things I love about this, our system, it's dry. So you don't have to like keep, you know, you see a lot of guys polishing and they're always putting water on the floor and making slurry mud and bringing it back. And it's, you know, like this is such an efficient system because it's all dry. It's fast track. You know, everyone wants everything delivered pretty quick. So, you know, you have an entire step. You don't have to prep the walls with poly for water. You know, it's very efficient that way. So guys, we're going to jump on the floor just a little bit quicker than we would expect to. But I just want to show you the speed that you can move the machine when you're polishing there. And again, I always like to run the vacuum there. You're always going to get a little bit of dust. So pretty much the same technique, guys. Always start away from the wall. And you can refer to your tooling guide. And there we usually turn the speed up to about 700. Do you see how much sharper that image is, guys? You can really see that round circle. As were before, remember on the 400? It was like, that was a little bit hazy. So that's what you get with the clarity. As you kind of move up, you'll get better reflection. So you get like that perfect mirror finish on your floor there. I'm not going to seal this floor because it's not quite, I'm using this as a training illustration. But the sealing is very much like the densifier. You do leave a little bit of a light film on the floor. We've got some videos there, and I'm going to include those video links. But the densification and the sealing are very similar. Before you seal this floor, you want to make sure it's nice and clean. You know, you've given it a good little wash there. If you have any issues with the floor now, don't seal it. Fix them, even if it means you have to go back a little bit. But the sealer is a high solids acrylic. And it's hard to get off, and it's meant to be hard to get off. So be happy with your floor. I even get the customer in sometimes. I'm like, are you happy with the floor? Is everything good? I'm going to seal it. So once I seal it, it's done. So, you know, just involve the customer if you can. You know, that's not always possible, but you know, something to think about. So it's always like a bit of a strategy with polished concrete. You're delivering that on the job site. So having that conversation with the customer, setting those expectations, all that kind of good stuff, and you should be pretty successful doing this. Well, guys, if there's no more further questions there, I'm going to log off there, and I'm going to send you this as a video. And if you have any other questions, like feel free and ask, no problem. Or you've got some job site pictures you want to send me, and you know, whatever, you've got a question or two, no problem. That's what I'm paid here to do. So thank you very much for attending the course. And good luck with your polishing.